Folks, welcome to Business 508. What I want to do to get started this week is make sure that everybody can get the solver that's inherent to your Microsoft Excel software enabled, and show you just a couple tricks in Excel here to start this first exercise. I just want to mention here that I am recording this video on my desktop PC, and it is my hope that the folks that are using a Mac out there, that you're seeing essentially the same thing I am. If not, let me know and we'll figure out a way to, if you need some help enabling your solver that's in Excel, we can get you some help. So the first thing we want to do to make sure that we have the solver enabled in Excel is let's go up here to the File option, click there, and we'll go to Options. And down this left-hand column, let's click on Add-ins. And at the very bottom here, next to the Manage option, Excel Add-ins is the option that we want out of this drop-down. So let's make sure that's selected and let's hit go. And over here in this window, there's a number of options that you can use to do sort of a special types of analyses in Excel. So for the first 4 weeks of the course, the option that we need to have chosen here is the solver add-in, and you see I've already got that checked for myself. And also, once we get into week 5, we'll start looking at regression analysis. So there's another neat feature within Excel that allows us to do regression analysis. So that is part of this analysis tool pack. So you can go ahead and click this now if you want, and then let's hit OK. And then to ensure that you have got both of these options enabled in Excel, let's go up here to the Data tab. And over here on the far right, you will see under the Analyze block here, I have enabled my solver, and I also have the Data Analysis tab. When we get to week 5, you can just click on this, then you'll see the number of options that are available here. One of them will be regression. And so the other thing I want to do while we're here is as you start working this first exercise in Excel, and really this is just a warm-up so that you can, so everybody's clear on how to use solver. And a couple of math tricks here in these 3 problems. Nothing to trick anybody up, just to kind of get us thinking here and get forward, as we move forward here into the course. So let me say here that this is, as I've noted in the instructions, this first exercise is going to be worked off or based off problem number 17 on page 307. And what I've given you here is really just I call this the Excel framework. It is the Excel version of what you see in the reading, and it's really the translation of the given information from the textbook and a way for us to sort of integrate this into Excel. And the magic now comes when we go to the solver and we look at, basically we're telling Excel how to think here. So there's some key things that we need to tell Excel in order to get this problem solved, and we're going to do that. Before I do that, let me close this up and let me, because I'm going to have to resolve this model. So let me zero out. This is the solution for the original problem, so no big deal here. So let me now go back to solver, and there's 3 or 4 key things here that we need to tell solver in order to get this problem done. The first one is we need to tell it the objective cell. Essentially, where in the model is the objective function being computed, and for us, it's in cell D20. We want that function, or we want that cell minimized. In this block here, that is titled by changing variable cells, you see E9 through E14. These are my decision variables, and by definition, this is once this model solved, the values of the decision variables becomes your optimal solution, and then the constraint. So you see the setup here, but let me reset all this, and I'm going to show you how to add all these things. So the first thing we want to do is we want to add the objective cell. So that's the spot in the solver where essentially here what we're looking to do is to minimize the cost of what needs to be made in order to satisfy this requirement for, I believe it's brake shoes, car brake shoes. And so we're just going to, once we have clicked in the set objective window here, we can just click on cell D20, and then cell D20 gets loaded as the objective cell. And again, that's computing the total cost that is required to make these products. And in this case, since we're looking at cost to make product, we want that cost minimized. So we want to minimize the objective function. You have these options here. All you need to do is click on the appropriate radio button, depending on what you want to do to the objective function. Now we're going to add the decision variable. So if I just click here in the by changing variable cells, what I want to do here, if I just go click on cell E9, and if I hold the left button down on my mouse and just pull this straight down, what you're going to see is I added all 6 decision variables at one time. So that's one keystroke, pretty simple thing to do. The next thing I want to do is I want to add the 3 constraints that were in here. So I'm just going to click on the add button. That'll allow us to start adding constraints. And we know the first thing is the requirement is to make 1,800 of these brake pads or brake shoes. So what we're going to do here is we're going to compare 2 cells. So the number made, which is basically the sum of all 6 decision variables, we want that cell to be equal to the number that's in cell E15, which represents the requirement. So that's the first constraint that requires us to make 1,800 brake shoes. The next one we want to add is, we understand here, or as we look here, there's a limitation on the amount of product that can be produced by each one of these machines. So each decision variable is going to be less than or equal to, and the less than or equal to is sort of the default here in the constraint window. And if I click on cell D1 and I pull all the way down, this essentially gives us 6 constraints at one time, saying that the quantity made by cell 1 must be less than or equal to 500. The quantity made by machine 2 must be less than or equal to 600, so on and so forth, all the way down the line. So we'll add that one. I'll say OK. And then the final one is the non-negativity constraint, meaning that all of our decision variables, once the model, or as the model is solved, all of them must be greater than or equal to 0. And there's a couple ways to do this. One is, if you look right here, there's an option below the subject to the constraints box. If you check that box, that will make all the decision variables non-negative. The other way, which is probably better practice, is simply to add a constraint. So we want to add a constraint that says all the decision variables, just click in E9, pull your mouse all the way down, change the direction of the inequality to greater than or equal to, and all must be greater than or equal to 0. So you can just add a 0 here, and we'll hit OK. So we've done all that we need to do to let Excel think for us. Again, here is the objective function value, which is being computed in cell D20. It's being minimized. The decision variables are in E9 through E14, and here are the 3 constraints in the model. For this week and this week only, there's a drop-down box here where you choose the type of solver that you want Excel to use to solve this model. Because of the way the objective function is being computed here in cell in cell D20, it's basically the sum of the variable and fixed costs that are associated with making these products. Because that's a sum, for some reason Excel does not like that, and the only way you're going to get these models to solve is by using the nonlinear solver. So just for this week, let's make sure we have chosen that. As we go forward, everything else that we'll do through week 4, we can do it with the Simplex LP solver, and that's the one we need. So now if we just solve the model, what we're going to see is that, first of all, we have made 1,800 brake shoes. And you'll notice the decision variables. Again, this is your optimal solution, the values of the decision variables once the model is solved. Each one of them is less than or equal to their capacity, and each one is greater than or equal to 0. So we've satisfied all 3 constraints, and we see that the total cost required to make 1,800 brake shoes is $42,300. And we can keep this solution, solver likes this, or Excel likes this, and we're all set. So I hope this is a good introduction to everybody. I really encourage throughout the course that when things are unclear, that you, I prefer that you put or post a note on the discussion board. Typically, you know, a lot of folks will find that their classmates may have a suggestion for them or a quick response. I will be on the board every single day, but you know, if you post a note an hour after I get through my work for the day, I don't want you to have to wait 24 hours. So and typically, like I said, your classmates will be very good about responding to questions on the discussion board. So put those questions on the discussion board, and that way everybody really will have immediate help. But again, don't hesitate to use that board. I don't want anybody frustrated throughout the course, and let's enjoy this, have a good time, and I hope this is helpful. If there's anything I can do for you, always please reach out if necessary. Take care and thanks.